Hello everyone, welcome to another lecture on reasoning ability and problem solving. In today's lecture, we will discuss some exercise questions from non-verbal reasoning based on diagrams. So in total, we have discussed that there are 9 types of problems that can be formed from non-verbal reasoning. Number 1 was series completion. Then it was matrix based questions, or you can also call them logical grids. Then we had a third type of mirror and water images. Similarly, fourth type was embedded figures. So these 4 types we have already discussed in the previous lecture. In today's lecture, we will discuss the other 5 types. That is, first was paper folding and cutting. Paper folding and cutting, 2 things you had to remember. First was direction of the paper in which it was folded, and second was incisions. Then dice and cube. Dice and cube, 2 concepts. First was adjacent and second was opposite facing numbers. Then counting figures, we were given a figure and we had to tell how many squares or how many triangles or rectangles were there in the figure. Then odd one out, we were given 4 or 5 images and we had to tell how one of the images was different from the others. And ninth was Venn diagram based. So Venn diagram based, again, simple questions. So these are the 5 types that we will discuss today. Okay, so let us start with type number 5, that is paper folding and cutting. This is question number 1. Now, we are given this. Over here, you can see the paper first is being folded like this, then it is folded like this, and then these incisions are made. Okay, now if I open the paper, I will open it like this, correct? So if I open the paper like this is still folded from this side. Okay, so if I open the paper, this small incision will look something like this, and this triangular incision will look like this. So I've told you that incisions are inverted, correct? So this will look something like this. Then we will open the paper like this. So when we open the paper like this, again the insertions will be inverted. So if I open my paper, I'll get this as it is. This will be here and this will be here. This is how my incisions will look like. So this is given in option number 3. So option number 3 will be your correct answer. Okay. So this is paper folding and cutting. Here you can see the solution. Question number 2. In question number 2, again a figure is given and we have to find how it will look after the paper is folded and cut. So this is a circular paper. Up till now we had what? Up till now we had rectangular paper. This is a circular paper. So it was folded like this, then like this into a quadrant. And then these incisions were made. So let's say this is my paper. Okay. So when I open it up, this much part. So the incisions over here look like this. I'm sorry, my drawing is not very good, but this is just to give you an idea. Okay. So this incisions look like this. So when I open it, my incisions will be inverted. They will look like this. Correct? This is a rectangle and a small triangle. So when I open, my incisions will look like this. Over here we had the folded paper. This much we opened. Then when I open the rest of the paper, my incisions will be inverted. So I'll get my incisions looking like this. This is how my cuts will look on the paper. This is a circle. So this is how my incisions will look. So this is given in which option? This is given in option number 3. So option number 3 will be your correct answer. Okay. Here is the solution. Question number 3. So question number 3 again. we are given a square paper. It is folded certain way, and then we have to find out how the incisions are made. So first the paper was folded like this, then it was folded like this. This is how we got the paper, and then the incisions were made. So when I open the paper, this incision will look like this. This incision will be a diamond, and this incision will look like this. Okay, and this incision. Over here we'll get a triangle, and over here also we'll get a triangle. Correct? Now, when I open the paper, that is this side. When I open the paper, we'll get diamonds over here. This incision will look like this, and this incision will look like this, and here also we'll have a diamond. So my incisions will look something like this. 4 diamonds, and over here we'll have 4 triangles. So this is given in which option? This is given in option number 2. So option number 2 will be your correct answer to this question. Clear? Can we move forward? Now, here you can see the solution. Then we have type 6, that is dice and cubes. So in dice and cubes, 2 concepts were there. First was adjacent numbers. So adjacent numbers can never be opposite numbers. Numbers or symbols. Correct? And then we discussed the concept of opposite numbers or symbols, and opposite numbers can never be adjacent to each other. So these were the 2 concepts, adjacent or opposite. So either or, that is the relationship. Now over here we are given 3 different positions of the same dice. So same dice is kept in 3 different positions. And we have to find the face opposite to the number 3. So opposite to the number 3 we have to find. Now when I look at this, I can see how many numbers are there on a dice? 6. 1, 2, 3, 4, 5, 6. 3 is opposite, we have to find. Over here this is 3, this is 5, and this is 4. That means 5 and 4 are adjacent to 3. So can they be opposite to 3? No. Then we have 3 and 4 and 6. So if 4 and 6 are adjacent to 3, can they be opposite? No. So 4 and 6 is eliminated. Now over here we have 4, 1 and 6. That means 1 and 6 are adjacent to 4. In figure number 2, 6 is already adjacent to 4. So 1 will come here automatically because 1 is adjacent to both 4 and 6. So over here also 1 will be adjacent to 4 and 6. So if 1 comes over here, which number will be opposite to 3? It will be 1. So 1 will be our answer, which is option number 3. Clear? Now, question number 2. Same dice, 3 different positions, and we have to find the face opposite having 1. Opposite to 1. Now, opposite to 1, if I see, opposite to 1. So, how many numbers are there? 1, 2, 3, 4, 5, and 6. Okay. Now, opposite to 1, I have to see. 6, 4, 2 are adjacent to each other. Okay, 6 and 4 and 2 are adjacent to each other. Over here, we have 4 and 2. So, if 6 has to be adjacent to 4 and 2, it will be over here. Correct? If it is this side only, then it will be adjacent to 4 and 2. That means 6 will be opposite to 3. So, over here, if we have 3, here we'll have 6 because 6 is opposite to 3. And if we have 4 over here we'll have 2. Downward. So, 5 will be opposite to 2. That gives us 1. So 1 will be over here. 1 will be opposite to 4. So 4 is in option number 2. So 1 will be opposite to 4. Clear? How we solve this question? Okay. So basically 1 was not given in any of the images. But based on the images, I found out that 3 has to be opposite to 6 and 5 has to be opposite to 2. So that leaves us with 1 and 4. So 1 will be opposite to 4. Clear? Question number 3. In question number 3, again, 3 different positions of the same dice. And we have to find the number opposite to the face having 3. So opposite to the face having 3. Over here we have 3, 2 and 6. So how many numbers are there? 1, 2, 3, 4, 5, 6, and we have to find opposite to 3. 2 and 6 are adjacent to 3, so I can simply eliminate 2 and 6. Correct? Then let us look at this 3, 2 and 4. So here I can clearly say that 2 and 4 are adjacent to 3, so 4 is also eliminated. Now we have 1, 2 and 4. So 1, 2 and 4. I can see 2 and 4 have a adjacent, that is 1. So if there is a number adjacent to 2 and 4, it will be over here. Correct? Only if it is in this position, it will be adjacent to 2 and 4. So if 1 is over here, 3 is over here, the opposite to 3 is 1. So option number 3 will be the correct answer to this question. Okay, here is the solution. Now counting figures. Counting figures means this is a figure that is given to us and we have to count how many triangles are there in the given figure. Okay, how many triangles are there? So let me just quickly give them names. This point is B, this point is A, this point is C. Let's see, this is D, this is E, this is F, let's say. This is G, this point is G, this point is H, this point is, let's say, K, this is J, and this is I. Okay, so A, B, C, D, E, F, G, H, I, J and K. So I've given them names, right? And I'll use a different pen to highlight the triangles for you. Now if you look over here, this is the main triangle I can see. This is what? This is B, C, D. Similarly, I can see this is a line going, so I can see two triangles, which is BAD and DAC. Correct? Now, if I look over here, this point, over here I see a triangle, or this point I see a triangle. This is DAI. Similarly, I see a triangle over here which is DAG. Correct? Now, I can see a triangle over here. This is DKJ. And over here I can see this triangle which is DHK. Similarly, I can see this big triangle which is AEF. And I can see this triangle, this one, these two triangles, which is AEK and AFK. Correct? Now I can see this small triangle and this small triangle. So this is what? This is JEH and JIF. Correct? Now I can see this triangle. So this is AGD. Similarly, we have AID. Then I can see this triangle DHJ. Correct? Any more triangle can be formed? Okay, these triangles I have not considered. AIC and BGA. AIC and BGA I have not considered. Over here I can see I have repeated some things. So D, this one, AGD and AID. AGD and AID are repeated. So instead of these triangles, BGA is not mentioned and AIC is not mentioned. Now we have these many triangles I can see. So in total, how many triangles are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12, 13, 14 and 15. So in total now I have seen 15 triangles and none of them are repeating. Let us check. So if you quickly go through, BCD is one triangle. Then we have BAD and we have DAC. Then we have BGA and then we have AIC. This is one triangle. Then we have DKJ. So KJ is this triangle, and then we have DHK, and then we have AEF. So AEF is this big triangle, and then we have AEK, so this triangle, and AKJ or AFK, which is this triangle. Then we have GEH, so GEH is this small triangle. Similarly, we have JIF, which is this small triangle. Then we have AGD, which is this triangle, and AID, and then we have DHJ, which is this triangle. So in total, without repetition, we have 15 triangles. Okay, so my answer will be option number 3, 15. Clear? So I by mistake repeated some triangles, but in total we have 15 triangles. Okay. Counting figures questions can be a little tricky, and they can also take time. So something like this, which is a easier figure, this will not take much time. But like the previous question, that was a big figure. There were in total 15 triangles. So 15 triangles, counting 15 triangles can be a lot. So sometimes counting figures questions can take a bit of time. So that you have to manage. I would advise you to, if you see such questions, keep them for the last, because they can be time taking. So when you have done all your questions that are your strength, only then try attempting the counting figures type of question. Okay. Question number 2, we have to find how many rectangles are there in the given figure. So rectangle, I can see one big rectangle, this one. Or if I give them names, it will be A, B, C and D. So I can see A, B, C, D. Then there is, let's say this is F, G, H and I. Then I can see 2 rectangles A, B, F, G and F, G, C, D. So this one and this one. Similarly, I can see this one. So this is what? This is AHID, and similarly over here also this is HBCI. Correct? Then I can see these 4 also. These 4 are also rectangles. So this is AHFE, similarly HBGE, similarly EGCI and FEID. So these are how many rectangles I can see. So this is how many? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in total I can see 9 rectangles. So answer number 1 will be the correct option. Okay. Now, how many triangles are there? Triangles. Let me give them numbers. So if this is A, B, C and we have D, E, F, G and this is L, M, let's say K, J, H, I. Okay. So I've given them names. Okay. Now, the first I can see is this big one, ABC. So ABC will be the first one. Then within this I can see AKJ. This is also a triangle, right? So I can see AKJ. Similarly, I can see this is also a triangle. So AHI. Now, then I can see ALM is also a triangle. So ALM. This is all the triangles I can see in ABC. Then in DEG, this is one triangle DEG. Within this I can say DLK. I can see DLK. Within this I can say DMJ. So DMJ. Okay. Then this one GDF. This is another big triangle GDF. Within this I can see GJI. Correct. And within this I can see GKH also. So GKH. These are how many triangles I can see. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So in total I could see 10 triangles. So my answer will be option number 4, 10. So as I said, my advice would be to keep these questions for the last, because they are tricky and they can take time until unless the figure is small. So this figure was easier comparatively, and this had only 10 triangles. But the first figure that we did, that had 15 triangles, and that figure was also complicated. So based on the figure also, just because of time management in your competitive exams, time is precious, time is money. So in your competitive exams, just keep these kind of questions for the last. Now we will come to type 8, that is odd one out. So odd one out basically means that certain number of figures are given to us, 1, 2, 3, 4, 5, and we have to identify which of the figures will be, which are different basically, which are not in the same logic to others. Okay, so over here I have a rectangle within which I have 1 dot and 2 dots outside. Then we have a pentagon which have 1 dot outside and 2 dot inside. Okay, so I can see 1 inside, 2 outside. Over here 1 outside and 2 inside. Then over here I see 1 inside and 2 outside. Over here also I see 1 inside and 2 outside, and over here also I see 1 inside and 2 outside. So only this figure has 2 circles that are inside. Every other figure have only 1 circle inside. So this figure will be the odd one out, which is option number 2. Clear? This is how you solve questions for odd one out. Now, question number 2. Question number 2, I can see certain arrows. So if this is what my arrow looks like. So every figure have 3 arrows and they are facing different directions. So if I rotate this arrow, okay, if I rotate this clockwise, it will look like this, correct? And if I rotate this again clockwise, it will look something like this. And again, if I rotate this clockwise, this will look something like this. It will look something like this, correct? So over here, I can see this is correct. Over here, this is also a rotation. Over here, this is also a rotation. Over here, I can see this is not a rotation, and over here, this is also a rotation. So in this particular diagram, this is in the wrong direction, because if my arrow is being rotated, it will have direction like this. So this is figure number, which one? This one. So option number 1 will be your correct answer. Okay. Now, question number 3. Question number 3 again. Certain figures are given to us, 1, 2, 3, 4, 5, and we have to find the odd one out. So I see in this figure, each column, we have column 1, 2, 3, 4 and 1, 2, 3, 4. Similarly, we have 4 columns in each figure. Over here, I see that I have an X in each and every column. Similarly, over here also we have X in each and every column. Over here, O is in each and every column, and over here X is also in each and every column. But in this figure, this column is empty. There is no O in this figure. So I can see that this particular figure is different than the rest. So my answer will be this one, which is given in option number 4. So option number 4 will be the correct answer. Clear? Then we have type 9 Venn diagrams. Venn diagrams, question number 1. We are given 3 words, Venus, planet and sun, and we have to identify the relationship between them and which of the following Venn diagrams represent the correct relationship. So I know that Venus is a planet. So if this is my planet, Venus will be a part of my planet. Okay. Now what is sun? Is sun a planet? No, sun is a star. So it is a different category. So I will have a different Venn diagram to represent the sun. So this is what my representation will be like. And this is given in which option? This is given in option number 2. So option number 2 will be your correct answer. Okay, clear? Venus was a planet. So Venus is inside a planet, and sun is a separate entity because it is a star. It has no relationship with planet. Okay. Question number 2. Question number 2, we are given pentagon, hexagon and figure. Now I know that we have many figures. So if this is my figure, I know we have many figure. One of the figure is pentagon and one of the figure is hexagon. Correct? One of the figure is pentagon and one of the figure is hexagon. What is pentagon? Pentagon is a figure with 5 sides. It looks something like this. And what is a hexagon? Hexagon is a figure with 6 sides. It looks something like this. Okay, so figure will be a bigger entity and inside which we will have 2 different entities, that is pentagon and hexagon. And this is represented in option number 1. So option number 1 will be the correct answer. Question number 3. Question number 3, rat, shoes and bat. I can see that all these 3 entities have nothing in common. Rat is an animal. Similarly, shoes is an object and bat is also an object. But does it have anything in common? No, bat is it is an instrument, or you can say it is an object used for sports, whereas shoes is a footwear. It is a clothing object, so nothing is in common. So they are 3 different separate entities. Rat, shoes and bat have nothing in common, so they will not overlap. This is represented in option number 2. So option number 2 will be the correct answer. So this is how you solve questions on Venn diagrams. So we have completely discussed the all 9 types of problems that you can get in non-verbal reasoning. This concludes today's lecture. Thank you.